All right, we're going to continue with Chapter 7 and Section 7.4, which is solving polynomial equations in factored form. So we have the zero product property. So the zero product property tells us if the product of two real numbers is 0, then at least one of the numbers is 0. So we're going to use the zero product property to solve equations that are in polynomial form or factored form. And what we're saying here is we're saying that one of those two parts of that equation must be equal to 0. We can set one of the parts equal to 0 and solve in order to solve the equation. So the algebraic kind of version of that says if a and b are real numbers and a times b is equal to 0, then either a is equal to 0 or b is equal to 0. So let's take a look at some examples. First one, we've got 2x and then in parentheses times x minus 4 is equal to 0. So what we're saying here from the zero product property is either the 2x has to be equal to 0 or the x minus 4 part has to be equal to 0. So in order to solve this equation, we'll set both of the parts equal to 0 and we'll get our solutions. So this part's pretty easy. If we just set 2x equal to 0 and we divide by 2, one of our solutions is that x is equal to 0. If we take our second part, which is the x minus 4 part, and we set that equal to 0, and we solve, add 4 to both sides, you'll get x is equal to 4. So what we're saying is both of these two values of x are solutions to that equation. If we plug in a 0 for x, we'll get 2 times 0, which is 0, times negative 4. 0 times negative 4 is obviously equal to 0. If we take the 4 and we plug it in for x, we're going to get 2 times 4, which is 8. 8 times 4 minus 4, which is 0. 8 times 0 is also equal to 0. So those are our two solutions to this equation. Same idea here. Set both parts equal to 0. So we'll set x minus 3 equal to 0. And we'll set x minus 9 equal to 0. Then you're just solving basic equations here. So add 3 to both sides. One of our solutions is x is equal to 3. Add 9 to both sides. And we get x equal to 9 as our other solution. Pretty straightforward. We'll look at the try these in class. Let's look at a couple more examples here. So the first one, we've got 2x plus 7 times 2x minus 7 is equal to 0. So again, set both parts equal to 0 and solve. Just a slightly more complicated example here. So we're going to subtract the 7. We're going to get 2x is equal to negative 7. Divide by 2. And you'll get x is equal to negative 7 halves. And then for our second part, 2x minus 7 is equal to 0. Add 7 to both sides. 2x is equal to positive 7. Divide by 2. And you get x is equal to positive 7 halves as your second solution. In letter B here, we've got x minus 1 squared is equal to 0. So x minus 1 squared is just the same thing as x minus 1 times x minus 1. We'll set that equal to 0. Notice that you're only going to have one solution here, right? Because we end up with the same equation twice. X minus 1 is equal to 0 on both of these. So we add the 1, and we get x is equal to 1 as our solution. So same thing here. We could have two solutions like we saw there. We could have one solution like we saw here. Here, we're going to set every single part equal to 0. X plus 1 is equal to 0. X minus 3 is equal to 0. X minus 2 is equal to 0. Subtract 1, we'll get x equal to negative 1. That's one solution. Add 3. X is equal to positive 3. That's your second solution. Add 2. And x is equal to positive 2. And that's your third solution. So as long as we're comfortable with solving simple equations, we should be pretty good with these examples here. We're just setting it equal to 0 and solving for what that value is for x. because once we find that value of x, we know that that particular part of our equation is going to be equal to 0. And if we're multiplying several things together and one of those things is 0, then the entire equation is going to be equal to 0. Now, in example 3, we're going a step further because now it's asking us to factor out the greatest common monomial factor from the given example that's there. So what we're looking here is we're looking for the greatest common factor. We're looking for the greatest common factor between the two terms that we see here. So I think it's easiest if you start by looking at the numbers and breaking it down into two parts. So you're looking at the 4 and you're looking at the 24. You should be saying to yourself, what's the largest possible number that goes into both of those? Hopefully you're thinking, okay, 4. 4 can go into both of those evenly. So what you're doing here, it's almost like you're dividing it out. You're saying to yourself, okay, I'm going to pull a 4 out of my equation here. So we're starting with 4x to the 4th plus 24x cubed. You're saying, okay, I can take a 4 out of those. If I take a 4 out of 4, I'm just going to be left with a 1 on the inside. If I take a 4 out of 24, I'm going to be left with a 6 there. Now, after you take a look at the numbers, take a look at those x's and see what can you take out of both of those. So you have an x to the 4th and an x cubed. And again, you should be saying to yourself, okay, I can take an x cubed out of both of them. So if I take an x cubed out of here, now you want to say to yourself, how do I get from 4x cubed to 4x to the 4th? Well, all I need to multiply times a 1 to get 4 to 4. How does x cubed get to x to the 4th? You just multiply by x. Plus, how do I get from 4x cubed to 24x cubed? Well, I have the x cubed part down. How do I get from 4 to 24? I just multiply by 6. So you end up getting an answer that looks like this. 4x cubed times 1x plus 6, or just x plus 6. And you can check to make sure that you did it right by distributing back. 4x cubed times 1x plus 6, or just x plus 6. If we distribute this back, 4x cubed times 1x is just 4x to the 4th. And 4x cubed times 6 is 24x cubed, which is what we got as our original problem. So you're looking for the greatest common factor when you have to factor out the greatest common monomial here. Now, on these particular problems, we're going to put these two things together. So we want to start by finding the greatest common factor to pull out of these, and then we're going to use the zero product property to solve. So if we look at 2x cubed plus 8x, hopefully you're saying to yourself, okay, I can take a 2 out of both of these, and I can take an x out of both of these. So we're going to factor out that 2x. 2x times what is 2x squared? 2x times x. And then how do I get from 2x to 8x? I have to multiply times 4. That's equal to 0. So now I factored out that greatest common factor. It's equal to 0. Now I can use the zero product property to solve. So I'm going to set both of my terms equal to 0. 2x is equal to 0. X plus 4 is equal to 0. And let's solve this. Divide by 2. 0 divided by 2 is just 0. Subtract 4. And x is equal to negative 4. So first thing you want to do is factor out the greatest common factor. And then step 2, use the zero product property to solve. And all that means is just set both parts equal to 0. Make sure you write this down. So if we look at letter B here, or example B, it's not equal to 0 to start. So the first thing we want to do is we want to set this equal to 0 by subtracting the 15n from both sides. So now we're going to have 6n squared minus 15n is equal to 0. Now that we have it set equal to 0, now we can go ahead and we can find or factor out the greatest common factor. So you're looking at 6 and 15. You're saying, what's the greatest number that goes into both of those? And that greatest common factor there is a 3, because 3 goes in evenly to both. And then say to yourself, okay, between n squared and n, can I take any n's out? And you can. You can take a single n out. So we take 3n out, then we have our parentheses. 3n times what gets me to 6n squared? Well, to get from 3 to 6, I need to multiply it by 2. To get from n to n squared, I need another n in there. And how do I get from 3n to negative 15n? 3 times negative 5 will get me a negative 15n, and I already have the n there. So there's my factored form. Now we're going to set both parts equal to 0. So we're going to set that 3n equal to 0. And we're going to set that 2n minus 5 equal to 0 and solve. So 3n equal to 0, just divide by 3. And you're going to get n equal to 0. And then 2n minus 5 equal to 0. Add the 5. 2n is equal to 5. Divide by 2. And we get n equal to 5 halves as our solution there. So our two solutions are n equal to 0 and n equal to 5 halves. You could always plug these back into the original equation to check your answers to make sure that they're correct. We'll look at the try these in class, as well as the word problem that you see here. See you then.